Okay, let's just quickly do a rundown of alcohols because they are very important. We want to answer the past paper questions and we see to do with alcohols because it's very important. Okay, there's going to be a lot on it, so it helps us to answer. Let's just quickly do it. We do a quick rundown where I show you some things to always remember when you do it. So for alcohols, we want to do the preparation reactions and their reactions. Just a quick rundown, which will take me 3 minutes or 4 minutes, whatever it takes me. So preparation reactions, where do alcohols come from? Well, first of all, we know that they come from alkenes. Okay, alcohols can come from alkenes if you hydrate them. In other words, if you have an alkene, so you have an alkene like this, we don't care what it is, like maybe here it's bonded to carbons here, and here the rest is hydrogens. So if I add water, okay, and in the presence of an acid, so it would be in the presence of an acid, H2SO4. The moment I see myself doing this to an alkene, then I'm going to get an alcohol. So we know that what happens is water has H and water has OH, okay? So H plus and OH minus, if you want to put it. So what happens is, where does H go? H is going to go, because we have these two carbons, the double bond should break. So we're going to have something like this. The hydrogen will go to the carbon which has more hydrogens already. Look at this carbon. It is bonded to hydrogen number 1 and hydrogen number 2. This carbon is bonded to a carbon and only one other hydrogen. So hydrogen will not go to him, but it will go to this one with more hydrogens already. And we'll end up having 3 hydrogens here. And then in here, on the other side, we have a CH3. And then we'll have the H, then the OH will come here and put itself. So OH will have to go to the other one. This is going to be the major product, okay? Then we're going to have the minor product where the opposite of this happens. So we will actually have H go to the carbon with less hydrogens. This is just a minor product. So for minor product, you can put it to show that you actually have your CH3 and your H and another H. Then this side, where we already had 2 H's, that's where OH will go, which is very rare. This is just a minor product, okay? So anyway, we are fine with alkenes. When you see us add water and sulfuric acid, we are not heating. We're not going to do any heating. We're not going to do anything. We just add water and sulfuric acid. We combine them. It's going to give us an alcohol. Then we have reduction ones, the ways to get there's something very important here, okay? There's something very important for us here, okay? Remember that, what are we adding? H2O. Now, to get what? An alcohol from an alkene. That's always what we're going to do. Then we have the second thing, which is going to be the reductions, okay? So we can say, here we have the reduction reactions. These are the other ways to get an alcohol, okay? Reduction reactions, all right? And for the first two, we'll be having one, aldehyde and ketone. So for aldehyde and ketone, we are going to have, remember, it's not important to try and remember where it's coming from or whatever. Just remember where to fix. I'm going to show you, because I just need you to remember where to fix. For aldehyde and for ketone, we remember reduction, we're going to use either NaBH4 in ethanol or LiAlH4. This is the stronger one. It's used in ether. So we are going to use what? LiAlH for the stronger one is used for carboxylic acids and esters. This one, the weaker one, is used for reduction reactions, okay? So we'll be saying, well, it's used for aldehydes and ketones. Still, all of them are used for reduction reactions. So for aldehyde, whatever the aldehyde you have, you can put it in any form. We don't care. We really don't care. So it's like if you have something like this, maybe. Should put it better. Here's my aldehyde. The double bond always at the last carbon, right? Then whatever, I'm going to add NaBH4. Please make sure it's NaBH4 and it is an ether, okay? Usually they put them both on the arrow. So even if we say we add NaBH4 ether, we don't all the reduction reactions for aldehydes, ketones, carboxylic acids, esters, what we know is that the double bond O will become an OH and everything else which was there should go, okay? And we have an OH just becomes an H. Everything else becomes H's and the double bond O becomes the OH. So anyway, we know that this is just going to be like this and this is just going to be now an OH, which also means there's now a hydrogen put somewhere, but we don't have to put it. Okay, remember it's a hydrogen, so it doesn't go on the skeletal formula. This is what happens, okay? It's the same for a ketone, eh? Even if we put a ketone here, we put our double bond here. Then we put same guy. Remember, we use NaBH4 in ethanol. In ethanol, sorry, not ether. This one you say ethanol. Then you say H3 H3O plus. Same here. You say ethanol, then you put H3O plus. We don't want to see this because we just know that whatever, we don't want to see it, okay? I'm sorry for the waste of time. This just becomes an OH. And for carboxylic acids and thingy, for carboxylic acids, we can have just then an OH, okay? This is the carboxylic acid. What just happens in reduction? We are going to put LiAlH4, right? And we say this is going to be in ether, and you put H plus. This is the stronger one because what do we have? This OH becomes what? An H. So we just have something like this. This OH. So now how many carbons do we have? 1, 2, and 3. So okay. So we can just put it like this. 1, 2, 3. This becomes an OH. Okay. This becomes an OH. You have 1, 2, and 3. That was this double bond O. It's now here as an OH. Okay, even if you put it to the other side, it doesn't matter. Doesn't matter. But that is what happens. The OH is gone. Okay, it becomes an H. That's just what happens. That's the same that happens for esters when you reduce them. The only other reduction which is left for you to know is for amides as they go to an amine. But these are all the reductions. The last one here is this one which I'm putting right now, which is for esters, So we can have something like this NO, which then continues, right? And on one of the sides, we have the carbon, which is bonding to your O. Here, it does a double bond with some O, like this. So this is your ester. And now what happens if I add LiAlH4? And it is going to be in ether, and we say H plus. What happens? Well, simple fixture. This guy becomes an OH. Then anything else should go and become an H. So this whole thing should go and become an H. So what we're going to have is going to be something like, this is 1, 2, 3, 4 carbons. So 1, 2, 3, then 4, like this. 1, 2, 3, 4. Then now we have an OH on the thing. Then we say plus. In here it is 1, 2 carbons. So it's going to be 1, 2 carbons. Then this O here is going to become an OH, okay? It goes with this and becomes an OH. Then what we have here, we remain with an H on this position here. This position, this double bond O is the one which you're seeing as an OH. Okay, remember the shapes kind of change. But there we have our reduction. Reduction is so simple, we can't waste time on it. The last 3 ways to make an alcohol is where we must focus. Here we saw how to come from an alkene. Here we saw how to come from aldehyde and ketone. The last 3 ways to make your alcohol, that's why you gotta focus. Okay, let's put those last 3 ways, right? I'm going to put the last 3 ways to make an alcohol. Let's put it. So here we have method number 2. So the number 1 here was hydration. So let's put it. The first one was hydration. And it was working for alkenes. We know for alkenes, we add water in acid and an acid. Okay, so now what about for the last things? What is it going to be now? Okay, so here we are going to have a halogenoalkane. Now the thing is, here's the tip. Whenever you have a halogen and you want to remove it and put an OH, you use NaOH. Okay, so let's do it. So for the next one here, which is your number 3. Okay, I don't know what to call it. We're trying to come from a halogenoalkane to go to an alcohol. So what are we just going to have? For the third one, we're going to have your halogenoalkane. Okay, let's say we put bromine here. And then I'm going to want to convert this to an alcohol. What do I add? NaOH. The last 3 is the one you should focus on. The other ones you know. For this one, add NaOH, okay, aqueous, NaOH aqueous, which is dissolved in water, okay, in water, and you're obviously going to get it, because what happens is you must know that sodium loves group 7, so he's going to take it. So what you end up having is you are going to end up having this OH coming. So remember to add NaOH, and then your sodium will take the group 7 for you. That's what is going to happen. That is what is going to happen. Now, what about if I have the same thing, a halogen, but not on just not a halogen like this on an alkene. But what if I have a halogen on a benzene ring, okay? We call it a haloarine. You should watch out for that. A halogen on a benzene ring. So if I come here and I put chlorine, how do I change this to an alcohol? Remember, we are changing to an alcohol. Remember that. How do I do that? I'm going to have to add the same guy, NaOH. Okay, I'm going to have to add. Why? I want to remove group 7 and put an OH. But now this is going to have to be, this is going to happen in 2 steps. So let me make sure I do everything right. Okay, so we add, what do we add? NaOH to remove group 7. So what then happens and put an A? Now what you must know is, here we then put 623 kelvins and 300 atmosphere. Okay, that's the one thing you should do. For the other one, we didn't have to put anything, but here we are putting 623 kelvins and 300 atmospheres. You say to me, this thing of just throwing reaction conditions, sometimes we don't have, most of the things that we do don't have reaction conditions. The things that have reaction conditions for alcohols, we only have this and dehydration of alcohols themselves when we are now removing OH from alcohol. But on hydration, which means to add water to an alkene, we don't have reaction conditions. Okay, we only have them for this one, where we are having a haloarine, okay, which is a halogen on a benzene ring, and we try to convert it to an OH. So here we do this. Then what are we going to do? Okay. Like this, okay? Then now what happens is, you'll be saying to me, oh, I know what happens. Na will take Cl. Yes, it will, but not now. So what first happens is actually, Na and O will go together. So you end up having Na plus and O minus, okay? Then what happens? We can start with the O minus and Na plus. Okay, and this just goes on. So now what happens is, when we add HCl in the second step, we will now then get our alcohol. So this one is a 2-step process, and this is a phenol, not an alcohol. That is how a phenol is made. Be careful so that you're good at doing this one, okay? Phenol is made by having this group 7 on your group 7. You have a group 7 on your thing that is attached. This is a benzene ring, I'm sorry. So we are going to have something like this, okay? We have group 7 attached on our benzene ring. And now what have we done? We have added NaOH because it gets rid of those. That's going to be a 2-step process. The Na and OH first. Then Na and O will first bond themselves on the thing. Then you add HCl and they will go, okay? And you remain with OH, okay? Because this Na will come for the Cl. And then you have an OH remaining. That is how it is, okay? Remember to first add NaOH and then whatever. All right, that's what happens. So remember, you add NaOH, the base. Then afterwards, you add HCl, the acid. Then you're going to get your phenol. Now, one other way to get phenol, which is part 5, that's the last thing. One other way to get phenol, you must know this guy. It's called aniline, which is benzene ring. Okay, so this is aniline. Now what happens is we want to convert this. We now have nitrogen and not a group 7 thing. We now have an amine there. So how do we remove him? How do we remove him so that we get an OH? Well, this is again a 2-step process. First, you're going to add NaNO2 and HCl. Okay? Then now what happens is, when we add these two, NaNO2 and HCl, we're going to end up going to get N2 plus and a Cl minus. Okay, these ends are connected by a triple bond. They connect to each other via triple bond. So it's going to be N2, and then now what then finally happens is we have so now what then happens is, yes, we put our water in the second step. We put water and we heat, okay? So what did we put in the first step? NaNO2 and what? And HCl. Then what did we get? Some funny intermediate. The intermediate comes from what? Nitrogen and chlorine, okay? Okay, it comes from nitrogen and chlorine. The nitrogen which remains and the chlorine here. So it comes from nitrogen and chlorine, okay? Then what happens is we will now add this and we will get our water. Okay, this is what happens. And here are the preparation reactions. I want you to remember the last 3, okay? Where we add NaOH to a group 7, where we add NaOH like this, and then here where we trap. Okay, so this is going to be NaNO2 and HCl. Then on the step is H2O. Okay, remember this. Try to remember it. We'll go to questions now.